What is attention in the AI field? At the seminal paper from Google in 2017, attention is all you need, is so important. I was like, what is that?
It's a focus on something, right?
Yep. At the expense of others.
You just need the attention matrix. And so that's where the name attention is all you need came from. And really the last almost 10 years now of a lot of AI evolution has been based off of this attention mechanism. There has been a lot of success in using an attention mechanism in imaging. That's what you'd call a vision transformer.
Hello, welcome to SpeechSage podcast, where we explore cutting-edge artificial intelligence, language, and implications in healthcare AI. Today we have Noah Vandal, who's a machine learning specialist, and with the topic of attention.
Attention.
Yes. So, what is attention in the AI field? And I was particularly interested in this because everyone says that the seminal paper from Google in 2017, attention is all you need, is so important. And as a AI field person, I was like, what is that?
What is it? Yeah.
So if you could tell us about what attention is first.
Sure.
Yeah.
Yeah. So I'll explain it. We'll have to step back a little bit, but if you have to interrupt along the way, just let me know. Well, okay. So the word attention itself, when we're just normally using it in common English, like what does that mean?
Well, focusing on something.
It's a focus on something, right?
Yep. At the expense of others.
At the expense of others. That's key. I mean, it's like when you're driving, right? Yeah, I mean, you're probably not really noticing the buildings that you're driving past as much because you're focused on the road in front of you. Your receptors are still taking that information in, but the focus is only on the next step. Well, okay, so machine learning is not a new field by any means. I mean, we've talked about this. It's been around for dozens of years. And around the 90s, people started experimenting with a framework called LSTM, long short-term memory. I might actually have the acronym wrong, but what the framework works, it's a type of what you call a recurrent neural network. And the thing about a recurrent neural network, the idea being, when you give an input to a recurrent neural network, it has a mechanism on the inside where it can take that input and what you'd call like a hidden state, and then recursively, so just do it in like a loop, try to predict what the output would be based off of the hidden state and the next input, and then the continued input in a continual loop. So there's a few different frameworks called like RNNs, recurrent neural networks, one being an LSTM, another one being a GRU, that started to become more and more popular for a bunch of different applications in like the early 2000s and even 2010s. Why do I say this? Like, why were they interested in this? Well, let's imagine you're trying to, for example, predict the stock market. You have historical data going back to 1910, 1920, whatever. And so ideally, if you could throw it into a machine based off of the past history, use a recurrent network. You could say, okay, here's the last 20 years. Now use recurrence to predict the next 10 years. Then you'd know, okay, buy NVIDIA. In 2017, that would have been a great idea. Buy
that would be nice.
It would have been really nice, right?
We
missed it. But anyway, that's the idea of a recurrent neural network. Well, a similar principle can be applied to things like natural language processing. A lot of research was done into natural language processing, specifically for the purpose of translation, right? It'd be so awesome back in 2015 if you could talk to me in Korean, English, whatever, and get it translated to whatever language with a really, really, really high accuracy using machine learning methods, not bigrams or other knowledge trees. Anyway, one thing that people innovated, I think it was 2016, was a particular implement a particular module in a recurrent network called an attention mechanism. What does an attention mechanism do? Well, an attention mechanism has three main parts you should keep in mind. The query, the key, and then the value. The query is kind of like, okay, what are you looking for? What is relevant in this case? The key is, okay, what information does our model kind of contain? And then the value is, okay, what should be the output of this response? Kind of, and that's a really, really high level look at it. That's like a really generic thing. But it works by using matrices that when you multiply them together, they're learned matrices. From it, you can understand, based off of the preceding input in a large matrix, what should be the best predicted output. It's a statistical probability mechanism that works by some sort of random noise that is trained, and based off of the data it's given, it can understand the patterns of what should be the next output. But then based off of that, they found that you are able to train these matrices and these mechanisms in a way that is a lot more reliable at predicting the next output. Now, that was before the paper Attention is All You Need. What they found out was, okay, you actually don't need the recurrent step. You don't need the recurrent module. You just need the attention matrix. And so that's where the name Attention is All You Need came from. They found out that, these recurrent networks, you don't need an actual recurrent network. You just need the attention mechanism in line with a few other machine learning matrices, and you can get some really, really good results. And really the last almost 10 years now of a lot of AI evolution has been based off of this attention mechanism.
So my understanding is that really revolutionized the translation function of Google Translator. And also more recently LLM. So how is attention used in those kind of field?
How is attention used for like translating or LLM?
Translating and LLM.
So in both of these, attention is one mechanism in the larger large language module. So in a large language module, you have a few different sub-mechanisms. One would be called your tokenizer. A tokenizer is what takes your raw text and converts it into embedding space. So that's the math of it. And another thing that is really important for attention is what you call a positional encoder. Well, essentially what that does is it says, okay, this is where this token is in this sequence. This is really important because in the attention mechanism itself, it doesn't necessarily understand the idea of position. It's not like intrinsic to the attention mechanism itself. Position is not. So by including that position encoder, you can basically force the model to learn where the position is. So at a high level, what's happening is in the attention, let's say you have a sentence that's 10 words long. And you want to make it 15 words long. You want to continue your sentence. So you give it 10 words, and what will happen is those 10 words get tokenized, and then in the attention module, it knows to generate another token, the 11th token. Well, that now makes it a sequence that's 11 tokens long. And then so that it knows it has to go to 15 words long. So then it'll generate another one. So now it's 12 words long. Then another one until it gets to 15. So that's what you would call an autoregressive model. But that's what most large language models are, is an autoregressive sequence. Something like a translate, that is a predefined, like you know how long the output should be. And so that one, it works in a very similar manner in a lot of the large language models. I don't necessarily know if Google Translate uses a pure large language model. They might use one that's based off of a technology called BART, which is slightly different, or BERT, I mean. But anyway, it's a very similar principle. And
so then how does that attention mechanism is used in AI, more specifically in the field of healthcare? So in healthcare, it would be a similar thing. So at the end of the day,
Do you remember those matrices I mentioned? The three parts of the transformer? They're the Q, K, and then V. So those are what you'd call learnable weights. They are a bunch of numbers that you train the model to learn. Now you train it based off of the data you give it. The data could be just raw, random data sets of medical information. It could also be some feedback that you give it to try to force it to have a correct output. When you are operating in a medical domain, let's say you want a model that's specific to medical, let's say you want a dementia-specific model. So you want to give it dementia data. What would change then is when you're giving it this data, in the process of training, the attention mechanism weights of the Q, the K, and the V matrices are going to be updated to then match the data that you're giving it. So for healthcare specific purpose, I mean, the architecture can be the exact same as like a friendly chatbot or as one that's for finance or for a car. The architecture can be the exact same, but then you can modify it, the weights based off of the data you give it and how you train it to then have a more of an inclination to be more healthcare specific. And that's where you would have an AI model that does so much better at a healthcare task than another model that was more generic would be because the way that they trained the data and the current way that the weights are actually stored are a lot more tailored for that.
And is that used in image data such as MRI or CT also?
It would depend on which model you're using. There has been a lot of success in using an attention mechanism in imaging. That's what you'd call a vision transformer. And that there's been a lot of really, really good success at using a vision transformer. And essentially what that does, I'm going to get a little technical here. Yeah. I won't go into too detail, but it uses a few small layers of a convolutional neural network. And it splits up in it. So it'll take an image like an MRI image, split it up into little patches, take those patches and embed them so they're in weight form. But then based off of those embeddings, just like a token, like from a language, you can then put that into an attention matrix and then it can learn what it's seeing in the image. Now, some people use those for MRI. Others will use a different architecture called like a convolutional neural network. And a lot of those, you can use convolutional neural networks with a transformer or with attention as well. Some of them do, other ones don't.
I see.
Yep.
See, how about the something like genomics, personalized medicine?
That's actually really cool. I didn't show you this, but there was last week but they released it was a large language model. But the only data it got was genomic data, like the base pairs.
No text.
Well, I mean,
it's a text, but no language.
It was
human
A,
language.
G, C, and T.
Yeah.
Yep, that was all it got.
Yep.
And it did it in 6-pair codons is how it trained. That was one token. And then it did an overlap. It was interesting to play around. They have like a little demo you can play around with. I'll link it in the video. But it was interesting to play around with. It wasn't great in terms of accuracy. But I can see like it's a startup. It was a small team. Still very impressive that it got the accuracy it did get. And I could see how it could just be scaled. But again, it's the same type of architecture that is used for word translation or for regular conversational. You're just changing the input data to that specific case. So I could very, very easily see a future where you have very specialized attention-based models that are tailored for a specific type of data, whether it is genomic data or even expression regulation or gene expression type data that can then maybe predict your how you express based off of your genetics. I'm not sure, but it's very much possible.
Yeah. Well, I mean, I think it is. Some people may feel that this was too technical for our podcast, but it is seminal paper and a very important concept in everything that we do in AI these days. So I was just kind of very curious about what it was about. But you explained it so well, and I feel like now I kind of understand why it was important, and how it is used in multi dimensions of healthcare AI. So
Yes.
thank you.
Thank you.